So I just wanted to give a quick run through of this new feature in OghmaNano, which is an improved materials database where you can script the materials with a Lua script. So we've always had a materials database, and if we say, for example, look at the perovskites, we can look at the MAPI and plot the refractive index, so that the refractive index and absorption. You also have emission in there. But we've got a new feature, which is this insert script feature. And this will insert a script into this material to define its electrical behaviour. So you can either have an individual script defined in each material, or you can have it outside the material as a general definition. So here, because we've got multiple perovskite materials, I've actually put the script outside the NK data directories, and it's here as this Lua script. So if we open that, what we can see we've got is we've effectively got the name of the material, and then we've got things like the band gap defined, the electron affinity defined, effective density states, things like that. And this script is used during the simulation to populate the electrical parameters. So if we go to the, so if we now sort of switch gears and look at a gallium arsenide device, so this is a gallium arsenide device, and you can actually find this in new simulation thermal modelling, and it's this gallium arsenide self-heating demo. If you look at the electrical parameters, people who've used OghmaNano before will be used to seeing the electrical parameters presented like this. They're just a number you can change, so you've got sort of electron mobility, hole mobility, and what have you, and this is for gallium arsenide. But if you click here and enable the scripting, you get this. It all says the values disappearing. It says C script values, and you get this new tab here, code editor, and this will now use these functions to populate these values when the script runs. And what's nice is you can make them effectively a function of temperature. So I'll just get rid of that. You can make them a function of temperature, so material composition, so X, Y and Z if you're dealing with alloys, and also photon density. And you can import a script from your material database by clicking on there and going import material script, and then say, excuse me, and then say inorganic, and then you can import, say, I don't know, aluminium arsenide instead. So this gives you a very, very flexible way to define material parameters. It also gives one source of truth, so rather than having lots of little parameters just defined arbitrarily, you can say, right, well actually it's coming from my database. So that's that really. And this is a full Lua interpreter, so you can put any equations or if statements or whatever you want in here, and it'll carry over to the electrical model. And it makes things like, for example, running things as a function of temperature very easily. So if we, for example, run a thermal simulation where we're doing self-heating with a JV curve and run that, so this is actually running at 330 Kelvin rather than 300, but all the parameters will have updated to represent this temperature. I think that's it really. I've included a lot of parameters in here, so most things have now got Lua scripts parameters in them. So perovskites have got one, the inorganic materials have got one. And also it's worth noting that the optical simulation, or whenever it, so in the, I don't think this will actually, yeah, we can run this. So this isn't actually meant to be a solar cell or anything like that, but if we look at the band structure, it is just gallium arsenide, but these parameters are all pulled from the Lua scripts as well. The final thing I think worth showing is that if you've got a script here set up, you can actually pull in the values. So you can say populate from script, and it will overwrite. So if you click OK, it will actually overwrite these parameters with what is pulled from the script. So you've actually got the best of both worlds. You can play with your values here, or you can have your script. So that's it really. I hope you enjoyed this video.